Welcome to another episode of the .NET Show. Now, today we're going to do something a little bit different. Now, you've all heard of HailStorm, but HailStorm isn't yet ready for developers to actually start writing code against it. So normally on these shows, I try to take and show you things you can actually write code against now. Instead, today, we're going to take and focus on what HailStorm is from a initial design perspective, what it took to think through the issues of implementing HailStorm, designing it, bringing it about, and talking with the architects and programmers that are actually preparing HailStorm so you will be able to code against it sometime in the near future. So hopefully that's the sort of thing you'll be interested in finding out about to help you with your development projects with HailStorm. Now, just a little bit of background, HailStorm is a service that allows you to expose calendars, contacts, personal information that an individual might want to store amongst themselves and store it off in the cloud somewhere. And HailStorm is a service that allows programmatic access to your calendar, your contact list. So when you go to a website that wants to schedule an event or something like that, they can actually schedule it against your calendar that you're using in your day-to-day life and not a separate calendar that's just existing on that website. Hopefully, HailStorm has some really great opportunities for application developers to write really great applications that can really affect our lives and help us work easier with our data. So stay tuned, and we'll be talking with Mark Lucovsky and Shaun Pierce about HailStorm. But first, let's go check in with Erica in the news.
Hello, I'm Erica Wiechers. Welcome to the MSDN News Update. At NetWorld Interop in May, Microsoft, IBM, HP, Borland, and others demonstrated SOAP interoperability across multiple platforms. This demonstration showed SOAP calls from Windows 2000 to Linux and from Windows XP to Sun Solaris. It also demonstrated the multi-language support for SOAP by showing interoperability between C++, Perl, Java, Visual Basic, and C#. In additional SOAP-related news, Microsoft recently released the final SOAP Toolkit version 2.0. This toolkit offers functionality similar to the MSDN SOAP Toolkit sample, which has been available for several months, but is a fully Microsoft-supported product. Using this new toolkit, developers will have access to a high-level interface that isolates the developer from needing to work with SOAP directly and instead use familiar COM-based interfaces. The toolkit, which includes an extensive set of sample applications, can be downloaded from MSDN downloads. Microsoft recently released the final version of its reference architecture for commerce. This is a set of software source code components that can be used in order to build business-to-consumer web-based solutions using Microsoft Windows 2000 and the .NET Enterprise servers. Demonstrated in this application are important features such as shopping basket, catalog searching, credit card payment, address book management, and many others. This application can be downloaded from the MSDN Code Center. To help developers gain familiarity with developing web services, Microsoft and DevX have created an online web services tournament. The tournament is based on a logic game known as The Prisoner's Dilemma, with participants creating software robots that play the game on behalf of their programmers. Both the infrastructure of the game and the player robots themselves are implemented as web services, an important part of the Microsoft.NET framework. As the game proceeds, players gain points based on the logic built into their robots, and at the end of the tournament, a winner is announced. A new round will be starting up soon, so be sure to check the links in the news transcript for more information. And that's been the MSDN News Update. I'm Erica Wiechers.
Technologies don't just spring forth so you can program to them immediately. Instead, we have to spend time developing them, thinking about some of the ways to implement some of the capabilities you're trying to add to them. And so I thought I'd spend some time with you today, not talking about a technology you can write code to today, but a technology that is in the birthing process, and talk with some of the people that are actually creating this technology so you can understand what they were thinking about, some of the design decisions they had to make, and why they're taking the specific roads and directions in bringing this technology out. The technology I'm talking about is what we currently codename HailStorm. And here to talk with me about that is Mark Lucovsky and Shaun Pierce. Now, Mark, you're kind of the head of the HailStorm project.
Yeah.
Now, one question I know that just before we get into the real deep technical things is people ask me all the time of why HailStorm? Why is it called HailStorm?
Why is it called HailStorm? Well, what happened was I was on another project team, and we were looking for a code name, and you know, the guy running the team said, let's find something nice and pleasing, you know, like think of rainbows and sunshine and stuff. So one guy in our group started thinking of the colors of the rainbow, and he said blue. That name is taken on the Microsoft network already. So he kept going down the color route, and I had my machine, and I'm trying to get rainbow. No, that's taken. Sunshine, that's taken. Rain, no, that's taken. And I hit HailStorm. Whoa, I got a name. And meanwhile, he got the name Green, which is now the name of another project. And I kept the name HailStorm dead on a server for months and months. And when our team split up and it was time to get a code name again, I'm thinking, wait a second, I already have a code name sitting on this website, so we'll just go with that.
So code name by server name.
Code name by server name, because you have to have a code name for your web server.
Yeah, pretty good.
So
in thinking about HailStorm, why did we bring about this whole model of the HailStorm architecture and the problems it's trying to solve?
Well, what we were trying to do is solve problems for real end users and put together a programming model that would do that and had some legs on it. So we wanted to make things like your address book and your calendar and things like that, you know, easily accessible by any kind of program. But at the same time, we didn't want to limit it to, you know, PIM kind of data. So we looked at, you know, your favorite sports teams or your top scores on video games and, you know, all kinds of things that were relevant to you as an individual. And that's how we came up on this, you know, my this, my that kind of naming convention. And you know, that kind of led to the partitioning and led to the overall design. So we ended up saying, well, you know, we'll take the universe of electronic information relevant to an individual, and we'll partition it along these, you know, high-level, top-level namespaces, you know, the calendar, the inbox, and the groceries, and the sports teams, and the wish lists. And then we'll also partition it across individuals. So we have, you know, my XXX, where my is the individual and the X is the namespace. So that's kind of the original thinking on the partitioning and stuff.
And also, the direction we're taking is different than what I think of a standard, you know, Windows API model. I mean, writing a Windows application, it's very much API generated. You're calling a method in the device. Where now it's more like this XML data blobs.
Yeah, it's a very different model. I mean, what we were looking at, number one, is we wanted to build these things as a set of SOAP-based web services, so that the API themselves, the messages or the methods were available on the internet, and you access the methods by sending a SOAP message to some endpoint, and it returns information. And we thought, you know, when you're coding to a normal API, you tend to have, you know, software distribution mechanisms available to you, so you can rev the API easily by giving out DLLs, and you're kind of in a standalone world. And we knew that in this world, shipping out DLLs to all of the call sites, you know, just because we wanted to change the back end would be a losing proposition. So we had to come up with a model where people bound to the services in a fundamentally different way. We wanted to encourage a very dynamic, very loose binding to the information that they extracted from the service and the information that they put in to the service. And it turns out XML is the perfect mechanism for that. I mean, when you're processing XML, by nature, it's a very loosely coupled binding to the data. You ignore elements that you don't understand, and you can use namespace qualification to extend the data in ways that are meaningful to your application. So we took that basic loose binding model and said that's the foundation for the service interface. So we take every service and present it to the programmer as if it were an XML file, and we kind of give you a DOM, or a document object model on the internet for these services, and we attach semantics and we attach structure to the services, but we let you navigate the data as if it was a local XML file. We find it to be a very powerful way of of dealing with the information.
Having it loosely coupled like that with just being XML data, almost random formatted, it sounds like it make it more difficult for a programmer to go against because they really don't know what information's there. It's just this data blob.
I don't really see it that way. I mean, our data is actually very, very highly structured, and Shaun and I, we're C programmers, so we're used to typing out C structures and type defs to define blocks of data. In XML, we're doing the same thing, only we're doing it with XSD schemas. So we actually have to think long and hard about, what is the type model? How are we going to navigate to this node? What's the meaning of this field? We're just using a different typing mechanism. We're doing it with XML rather than C structures. So we actually have a very formal type system for all of these services. It's just a different type language, and the data itself comes out as tagged XML rather than binary C structures. So it's very similar to what you used to do with C. The benefit, though, is that when you're programming against it, you can very easily transform the data using XML processing techniques. You don't have, in C, when you're programming to a C API, you tend to find a lot of places where people take an operating system structure and they need to embellish it with their own application-specific data. So they'll do field-by-field copy scripts and end up writing very fragile code against a binary structure, where if the binary structure changes and they're not tracking that, or they have no way to track it, their code blows up. And sometimes it's Microsoft changing a structure. A lot of times it's the ISVs themselves. They were either sloppy in the beginning or they changed their own structures and they broke because of it. XML encourages you to process the data on the fly by using the tagged elements. So it's
you're parsing it every time.
You're kind of parsing it every time, and you're writing handlers for certain elements. So if you're using a SAX technique, you run the XML that you extracted from the service through a processor that says, okay, I hit this element, I hit that element, or I hit this attribute, and you can be very event driven, but you're very loosely tied to the data. So it's a great format for dealing with this kind of information. It's not for everything. I mean, I don't know if I would build GDI like this, or I wouldn't build the argument list to read file or write file to this, but for the kind of data that we're presenting with HailStorm, calendar data, mail entries, wish list, favorite this's and favorite that's, document metadata, it's very, very appropriate.
But it is very different than what we've done in the past with things like this.
Yeah, what we're not doing specifically is we're not building an object model or a class hierarchy on top of this data.
Because, why not?
Well, what the power in these HailStorm services is that, while we might present a document as having this much metadata, you, the programmer, can extract whatever piece of that metadata or whatever subtree you like. So we kind of have an infinite set of classes where the programmer is defining the boundary. Like, for instance, if I want to mimic an email distribution list, I might take the My Contacts service and thread a category through each of the contacts that are part of that DL. And my query might be, enumerate the address book and give me the email address nodes for all contacts that are part of this distribution list category. Well, in a typical object model world, I would create an email distribution list thing, and the format of the thing was fixed, and it always meant this. In HailStorm, it's free form, and if an application wants to say, to me, when I think of a distribution list, I don't want the friendly name of the email address. I just want the email address, and I want to constrain it to only things that have this category. It's a very natural thing to do. You don't have to have Microsoft define the boundaries for you like you would in an object model. You manipulate the data in the way that makes the most sense for you. And if you think about it as how would I scale these solutions down to cell phones and Blackberries and pocket PCs and Palm devices and payphones and car stereos and full function PCs, they all want to treat the data a little bit differently. Like if you use a BlackBerry, your mail doesn't, you don't think of your mail as being in my inbox and my sent items and my this and my that. I mean, you see basically a flat list of mail messages. If I create an object model and say this is the only way to see the data, then the guys writing the code for these teeny form factor devices, they're scratching their heads saying, wow, I have no choice but to use this object model, even though fundamentally I don't have folders. Folders aren't part of my world. So with HailStorm, we're trying to address that, and we think the way to address it is with loosely coupled binding to the data.
So this adds a level of flexibility then that makes it more easier to write more different types of applications that maybe we're not thinking about right now.
Yeah.
You're going to say something, Shaun?
I was going to say that it doesn't force us to have a client-side library on every single platform that we want to support. So that was another key thing.
Yeah.
Yeah. And that is a huge thing because, let's face it. I mean, we're in a diverse world, and even if we were in a completely uniform world, the different people want to process data in different ways. I mean, even in Win32, when I look at Microsoft Word from ages ago, even though in Windows we had an API for saying, given this file, what's the change time and what's the file size, Office would wrap that and present it to its software in a different way. They didn't like our data structures, or they weren't a natural fit to the software that they were working on. So they would have to wrap the DLLs. Well, if they're going to wrap this stuff anyway, why not just give them direct access to the data and let them come up with the structure that's right for the application? So everybody wants to process it differently. We might as well accept it and encourage it.
Mm-hmm. Now, in deciding the schemas for these different data packets, the My Contacts and the My Wish List and so forth like that, how are you actually working on defining what information is stored in each one of those packets?
Well, I think you use a little bit of common sense and a lot of collaboration. So, for instance, in My Address, we tried to think through, okay, what kind of addresses exist? There's, physical addresses, Earth locations, there's websites, that's kind of an address, telephone number is kind of an address, screen names, that's kind of your instant messaging address. So we came up with, the coarse-grained things that we could say this makes up an address, and then we worked through a design process to say, now, if you really were to look at what an address is, a shipping address, what are the components of an address? And we worked with, teams all around the world to say, it's very tempting to say, well, an address, how hard could that be? It's street, city, state, zip code, country. Well, that's a very US-centric view of what an address is. So, we worked with all our localization experts and with the geography teams and with the guys doing GPS positioning, and we arrived at what we think of as, a HailStorm address. It deals with primary and secondary cities, official and unofficial address lines, postal codes, varying postal codes. So we think we can, represent, all addresses worldwide. UK has some, very, very different demands on an address than what we would have in the US. We do the same thing for phone numbers, even for names. People, if you look in the My Profile service, you think of a name as, oh, that's easy, first, middle, last. Well, there's titles, there's suffixes and prefixes. There's an order to the names. In some countries, you might naturally file the name as first, middle, last. In others, it might be last, middle, first, and middle, first, last. And some names, it's very common to have the name be in one language, but have pronunciation and the character coding for the name be in a different language. So there's localization demands on these things, and so it's easy to do the first round, but there's a lot of polish that goes onto the schema that we go cross company and cross community on.
Are there any standards in place, like W3C style standard or BizTalk standards that you could use
For things like that? Well, originally I thought, oh cool, how hard could address be? I'll go to biztalk.org, or I'll go look it up on the internet. It turns out there are no good standard schemas for worldwide addresses. I mean, people might, after hearing this, might say, well, I know of one. Well, we did the internet searches and found reams and reams of guidelines for, what are the components of an address in this country, in that country. And that's how we arrived. We took all these sources of information and said, okay, this is how we factor all of that into an address. And we're just picking on address right now. You can imagine what phone numbers are like, or what some of a mail header would be like, or an event on a calendar. So we have to do that analysis on every single XML tree that goes into our system. And that also kind of brings us back to the object model issue. If we were on the path of an object model approach, each time we come up with one of these refinements, we'd have to say, ooh, we have to expose this as a property on an object, and the property has to have a name, or if it doesn't have a unique name, then it's a collection of similar properties. If it's a collection, what's the indexer on the collection? If let's just say in some country in the world, they tend to have 17 middle names. So a name looks like first name, middle, last name. How do you represent that easily in an object model? You typically have a method or a property called first name, and then an array of middle names, and then a single last name. What happens when you come along and find a country where it's very common to have two last names? Do we now invalidate that object and say, ooh, we have now last name is an array, and here's the indexer? With XML, you just say, well, I'm looking for the last name nodes, and you get two of them, and you can index them any way you want, or you can say, well, just call me for each name. I don't have to do the indexer. The XML parser does that for me based on the presence of the node.
Boy,
So
I'm sure you spent a lot of time focusing on those issues, it sounds like.
we're still focusing on it. It doesn't end, unfortunately.
Do you find that a lot of other people in the company and outside the company are offering to help you define some of these schemas, either in a good way or a bad way?
Yeah, I was going to say help is sometimes a loaded word.
Yeah.
Yeah, we're getting lots of help. So it's interesting. I mean, it's fun doing the polish, because I had a debate with some of the localization guys today about basically Asian names, and if our language tagging is strong enough to represent all of the combinations. Like in Korea, it's not uncommon to have the name be in Korean but use a Chinese character set. So how do you represent that for localization? You have to tag the thing as, oh, this is Korean with Chinese characters, or this is Korean with Japanese characters, or this is Korean with English characters, or this is an English name. It's a English spelling of a Korean pronounced name. So there's a lot of work that goes into it, and we have huge teams of people that are specialists in each of these areas. So
I think we've covered then fairly well the data structures that are on a device. Then we actually have to move those data between devices. So I've got to take them from my application, call the HailStorm services, and get data back again. Now the choice we used there was using SOAP as kind of the underlying protocol. What were the design reasons for that?
Well, SOAP is a pretty simple wrapping technique. I mean, what are your real choices here? You can say, I'm going to create a session and then do binary RPC between two endpoints. Well, that's just not a scalable solution for an internet approach. You need a good stateless posting mechanism. And so typically people have been doing that with DAV, which is essentially an HTTP post, and the format of the post body has meaning to it, that it has a set of verbs and some data. Or people would build HTML forms and post the forms, so each the receiver of the post understands the data structure. SOAP formalizes that by saying, when you post this thing, the structure of the body, the post body, is an XML document that has an envelope wrapping a set of headers with a set of bodies. So it's a nice formal way to carry your argument list and kind of your call stack. So you'll see things in our message format where you describe your identity. Typically in a API-centric model, you'd find the identity by doing something like get current thread or find the token of the caller. In an RPC style mechanism or in an asynchronous post mechanism like we have in HailStorm, you have to transmit that with the message, or you have to set up a session and tie that context to a session. So since we're sessionless, we have to transmit that on the call. We have to know what document you're after, what's the location of the service endpoint. Once you get to that service, what do you want to do with that document? Are you trying to do a query, or are you trying to send a mail message? So we just use SOAP as a way to package all that information in a nice structured XML way of doing things. Very natural approach. All the other approaches seem ad hoc and fragile, I mean, to be honest with you. So I think this is the right way for people to do this kind of service on internet scale.
Did we ever consider jointly a binary protocol of smash down SOAP or anything like that? I don't remember.
I know that there is work going on for binary SOAP. One of the beauties of XML is that it is a text-based format. It's a little verbose, but it's easy to read, easy to debug, and it's very easy to compress. So while the XML looks big and bloated and slow, I mean, you got to think about, hey, it's a text-based protocol, so you can use in-stream compression techniques to make it almost as efficient as binary. It won't be pure binary, but with binary you have the obligation to pretty much ship binary runtimes so that people get the fields right. I mean, if an address is a 4-byte field, you got to help the ISV construct that 4-byte address. If I have a text-based protocol, it's easier for them to construct that address because they can do it with stircat if they want to. They can do it with hard-coded strings. They have a lot of different ways of doing the same thing. Whereas a binary format, they're pretty locked. They either copy our structures or use our binaries, and both of those get fragile over time.
Yeah, they'd have to understand the entire thing or nothing at all.
They'd have to understand the entire thing, yeah.
Yeah. Now, in passing this data back and forth, I mean, like talk about the fact that it's all text, and so it's going to be a little bit bloated, but you can compress it down. Mm-hmm. It's still not quite as compressed as it, like you said, a true binary could be.
Right.
Is there anything preventing HailStorm from having a deep binary model that's passing between servers it knows about, or?
Oh, no, not at all. I mean, that's just not our V1 design point, is really get the services up and running and make sure that people can call them. So, we're doing source code distribution of the client bits. We're bending over backwards to say, this is how you consume HailStorm. Here's, end-to-end code that interoperates with it. You can call it from your Perl scripts or your Java scripts or any language you like, any platform you like, and here's how we did it. And this is a starting point for you to use. If we went binary route, it would be a much tougher sell. Then I'm going to have to develop, here's the binary structures, and I have to worry about, is it big Indian or little Indian? Does your C compiler insert padding between a byte followed by a D word? All those issues that, that was our previous life for years and years. So we kind of want to get away from that a little bit.
In thinking about going multi-platform, are there any trade-offs or concerns you had to pay attention to make sure that it did work on all the different types of systems might hit?
Well, I think that one of the things, and we talked about this at the announcement, a lot of times this open access from any platform, that's how we think of it, becomes a goal of a product, mm-hmm. but not a requirement. And for us, it's not that it's a goal, it's a requirement. So we have a Macintosh and a Linux machine and a Solaris machine and a Pocket PC and a Palm 7 And we kind of developed those codes, the ability to call HailStorm. You know, we did Pocket PC first and Linux second, I believe. I mean, we're actually, you know, fulfilling these goals by making them hardcore requirements and doing that work early, developing the source code, knowing that we're going to be distributing it in source form and expecting it to run on lots of different platforms. So, you know, will we, in the sample source code, take advantage of something that we know, hey, this API or this technique is only there on Windows? I mean, sure, we're going to do that. But at the same time, we're going to say, you know, hey, we realize that, you know, this kind of scatter write operation is there on Windows, so we better, in the sample source code, demonstrate the path where if you don't have this capability, then use this other technique at the same time. And, you know, expect it to be a collaborative process with the community.
So what about EBCDIC?
EBCDIC, yeah, we do that too. XML probably has EBCDIC encoding formats, so, yeah.
What are some of the issues you think that maybe our audience might appreciate and understand a little bit more about the work you put into getting HailStorm working for them?
Well, I don't know. That's a good question.
It's all about a schematized store.
Yeah, it is. I mean, you know, at the end of the day, HailStorm feels like a partitioned XML database, and you got to treat it like an XML database. Don't expect it to have, you know, gobs and gobs of semantic helpers, and you know, it is what you make of it. So, you know, if you want to do calendar aggregation, this is how you do calendar aggregation. If you're going to get frustrated that you're going to have to do the joins, you're going to see that. I mean, you can't do a cross ID query and say, give me the free busy days for Mark's calendar and Shaun's calendar and give it to me in one merged document. You're going to deal with HailStorm by saying, give me this calendar and that calendar, and then I'll use an XML processing technique, either iterating over the nodes or writing XSL to merge the two together. So, you know, people need to start learning how to deal with XML now in their applications, and they'll do great. I mean, I know it's possible because, you know, I'm not an XML guy. I mean, you know, Shaun and I are hardcore kernel guys. I've been doing NT for years and years, and here I am writing schemas. And, you know, I was warned many times by Cutler that if you ever hear the word schema, run. And here I am, you know, doing schemas and typing XSDs and saying it every day and working on it. So it's not that hard. I mean, anybody can learn it and have fun doing it. It really is a lot of fun.
Okay. Well, thanks, Mark, and thanks, Shaun. You've been talking an awful lot this time. We're going to get you in a few minutes here. Yeah. Mark, once HailStorm's out and running, I hope you or other people from the team can join me for another show where we actually talk about developing HailStorm application, what that means. But I appreciate the time you spent with me.
Sure.
Okay, great. So hopefully I give you some insight on some of the thought processes that we've taken in developing the HailStorm API and technology. Like I said, this is not something you can program to today, but hopefully very soon. Now, we've got a short break here, and when we come back, Shaun's going to show us something about what the HailStorm XMI and XML code looks like. So stay tuned.
Don't know much about positioning, don't know a thing about marketing, don't know much about the analyst. I just sit here and watch the bug list, cause I do know where the blue screen rests. And I know that if this code just works, what a wonderful world this would be. Cleaning up those hard-coded paths, bad heat management ensures your wrath. No overriding of the system files, and I check the version once in a while, cause I know that 1 and 1 is 1. And when cleaning up my code is done, what a wonderful world this would be. Now I will claim my code is compliant, cause you want it to be. Cause surely by being compatible, baby, I can win your loyalty.
man. You're gonna love this. It's so cool.
'Cause I do know where the blue screen lurks. And I know
Watch
that if
this.
this code just works, what a wonderful world this would be. La, la, da, 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 da,
Hey!
da.
These guys are the customers.
Reliability.
See if you can guess what I am now.
Make sure it works.
A bad device driver. Get it?
And I know that if this code just works, what a wonderful world this would be.
Welcome back. We're going to cover some more details about HailStorm now, and I realized the first segment was a little bit more on the not too deep in the technical aspects of what HailStorm really is, and you probably want a little bit more you can chew on. So I've got back with me now Shaun Pierce, and Shaun's going to take and walk us through some of the actual code involved in the HailStorm schemas of the data models. Thanks, Shaun.
Hey, so I thought I'd take us through kind of a sample of a HailStorm service we call My Address, and Mark kind of talked us through that almost all of HailStorm is about a schematized access to storage. So we've broken up a My Address schema, and this would be one of those HailStorm services that lives up in the sky. And you can see here that you got some XML basically that describes this schema, and a lot of the actual data is left out, but so you can kind of see the structure of what this thing would actually look like when you're going to go do a query to the My Address service, what kind of information you'd get back.
And so what we're looking at here, it looks like it's it's XML description of the data that will be XML data then.
That's right. This will be an XML document, and this is the storage of your data. So you'll see we've got stuff in here like, on this line here we've got official address and, like what Mark was talking, primary city and secondary city, because we found that there's all these different ways to represent this data across all the different countries in the world. So there's really no data here, so you can't really see like what the values would be in here. But this actually gives you kind of a good overview of what the structure of one of these services would look like. And it basically looks nothing more than just an XML document.
So in something like this, we were talking about the last name second has an array sort of thing. So we have primary city and secondary city. Well, what if I had a third city involved? I mean, isn't that the same problem that we have?
Same problem. Only in this particular case, since this is XML, we have a bunch of elements here. So, like let's say you live in a country where you have two postal codes, so these two elements can keep occurring over and over and over again.
So I'd ask for postal codes, I'd just get multiple postal codes back, and then I could pick the one that was appropriate or whatever.
Part of the query that you would feed to this thing is you'd say, hey, I'm interested in postal code, and you have to be prepared for multiple results to come back and be able to deal with that. So in this schema, this is actually a reduced schema, so you don't see in there things like we have these attributes called min occurs and max occurs, which says I know that there can be at least one of these things, or there might be multiple of these things, or you can say a max occurs of unbounded, which would mean that we could have unbounded amounts of postal codes in there. So when we author these schemas, we can say that, hey, I know that for this first name there's only going to be one, or there's going to be at least five, or so that's how we kind of declare these HailStorm services up front to say, I'm pretty sure that I should only see one of these, or this could be unbounded, or whatever.
And that's used in order to validate the XML data on the servers.
Yeah.
And also, I suppose, the application developers, so they can understand what to expect back from the data.
Right. So they'll have a stable asset to code against, so that they know if I do a query to the first name element, I'm only going to get one of these, or I'm going to get multiple of these. And it's important to note for each one of these HailStorm services that this schema is public on the internet. So you read the schema from any one of these services and you know exactly what you're going to have to code to. So it's not like you have a client-side library with structures and stuff like that, and you hope that those are in sync with what the server is actually running. In this particular case, you do queries to the server to find out what is the schema, and that's always live and up to snuff, up to date.
Now, we haven't talked much about the security issues involved here. How are we dealing with security? I mean, I'm seeing data here that can be rather private data,
Right.
and yet to a certain extent HailStorm is intended to be called and retrieved by almost anybody.
Right. So what we have in place is a Kerberos type of authentication model where you go to Passport and you authenticate to Passport, and then from that point on, Passport can vouch for who you are to any one of these services. So once you've authenticated to Passport, it can vouch for who you are, and then if I want to look at your data, you have to allow me to do that. So there's like a roles is kind of an ACL of what we have. So I would say, hey, I want to look at Robert's portfolio. Robert's my portfolio. In order, I would go to Passport and I would say, hey, I'm Shaun. I've proved that I'm Shaun. Now I want to go look at Robert's portfolio. And
I'm not going to let you see my portfolio.
Yeah, you would have had to have let me see your portfolio for that to have happened.
Now, is that an all or nothing thing? So you either can see my portfolio or you can't?
It's what the roles actually dictate, and whoever created the service gets to dictate what the roles are for any given service, but the roles actually dictate what methods I can call or what SOAP messages I can shoot over to the My Portfolio service, and also what data fidelity I would see. So maybe if you trusted me as your broker,
that chance.
all I could see would be maybe your shares of the stocks that you own, but maybe not positional information. Mm-hmm. Does that make sense?
Mm-hmm. So how much of the data you could see is not a black and white thing.
Right.
So even if you have the schema model down and you know what the fields are, you can't be guaranteed that all those data will come back to you. It all depends upon how trusting I am of you.
Right.
So in another case, in which case you'd probably see none of my data. But then another issue is that how do I as a user actually control that security though? I mean, is that a difficult thing to do, or?
No, it shouldn't be hard at all. We've got kind of this ACL editor that you can use, and for any given site you can say I'm willing to let this site or this person see my data, and I want it to be good for a day or just for this operation, or those are the kind of things you can do. Mm-hmm. We're still actively working on what that looks and feels like, so. But it shouldn't be difficult at all.
I take it security is probably a pretty big thing you guys are looking at.
Oh yeah, absolutely, absolutely. We've got an entire organization whose whole job is to make sure that this stuff is secure, because people's data we wouldn't want it to get out to anybody.
Okay, why don't we continue walking through the code then here?
Okay, so all this stuff is the schema. There's not much interest in here, just to show you kind of what an overall schema looks like for us. So I thought I'd actually dive into a little bit of, now that we know what a schema looks like, what are the SOAP messages I need to send to it to actually manipulate the data within the schema? So I got to page back up here a little bit.
Pretty big document.
Yeah. The basic operations we can do, we've got like five or six, I guess you could call them atoms or operations or messages you could send to any HailStorm service. So every HailStorm service will support these methods. So what we're trying to build is this common platform asset where all these my fill-in-the-blank services, you actually talk to them the same ways, you issue the same requests to them, and everything looks and smells very similar. So ISVs have this stable asset to code against.
So every time you open up a new type of service, you don't need to relearn the entire model for going against it.
Okay,
do we envision there being new services just constantly popping out of the ether, or do we expect to have a core set of services that happen, and that's basically what's going to exist for quite a while?
Honestly, I'm not sure I know the answer to that. I know we're going to come out with these core set of services, but we fully expect and are hopefully encouraging ISVs to develop these services as well. But we're actively learning how to bring this stuff up, and we know we're going to deliver these core set of services, and after that, I think the sky's the limit. We definitely want ISVs to engage, not only to consume these HailStorm services, but also to create their own and have other ISVs.
So from a design standpoint, it's almost like slightly organic from that standpoint.
Right.
So when Windows comes out, that's Windows, and you don't get another version of Windows till the next version comes out. Where here, HailStorm services can be rolled out as appropriate.
Right. And we also think that Mark talked a little bit about this, but we also think some of these schemas can change, which is important for why we wanted to have like this open access platform where all I have to do is send a SOAP message to this thing, and if me and you decided tomorrow that the My Address service looks like we forgot a few things, we could make that schema change and not have to update, all the code on every platform that ever wanted to call this thing. It's just that we publish a new schema on the service and we say, hey, we've added this new field, here it is, and the people that used to code to the old model, well, they've never known of that field, so they're not going to break. And the new people that want to take advantage of that field, they would just instantly start working.
So like on the my address thing, let's say in addition to primary city and secondary city, maybe we decide we want to add sister city or something like that to it. We would just add sister city into the XSD document, and it would just be available then?
It would just be available, that's right. And old applications that were coded not knowing about sister city they wouldn't know about it, so they shouldn't break. And the new applications that found that I want to leverage sister city, they could start storing information in that, and they could.
But if they're reading a document that didn't have sister city stored in it, wouldn't they expect it to be there and break there? Or no, they wouldn't necessarily expect it to be there, since they don't know exactly what the security settings might be, so
Right.
data might be there or not be there. So
Right.
they need to be robust enough to not fail
Right.
if something's not there they
Right.
expected.
They should get in the habit of coding to only what they knew as a schema, and be looking for those fields and to ignore things that they don't know about.
Okay.
So with every HailStorm service, we've basically got 1, 2, 3, 4, 5, 6 primitives here, and these are the SOAP messages that you'd send to talk to any HailStorm service. Now, for some HailStorm services, there are going to be other what we call domain-specific methods, which is extra additional business logic for any HailStorm service, like maybe for my notifications, it's like an add notification method or something like that. But anytime where you might need some extra business logic. But for almost every single HailStorm service, you've got these, on every single one, you've got these 6 methods that you can always count on to manipulate the data. And so we've got operations like insert, delete, replace, update, query, and change notify. And the first couple of these guys are all data manipulation, like insert, which is, I want to insert some data into this XML document that represents your data or my data. So I ship over an insert request. Or delete, I want to delete something. Or replaces, I want to replace an operation, and that's basically thought of as an atomic delete and then an insert after the fact. So it's just a replace of what's there. Update allows us to cat together a bunch of these guys all in unison, and query allows us to query the database. Last guy here is kind of a strange animal, change notify, and that's basically, I say that I want to register a notification at your data or whatever data you're trying to get at, and I'll get a notification back if you change it, or if somebody else changes it. Does that make sense?
So like on my address, let's say I'm storing my address and you are some company that I've registered to receive monthly shipments of coffee from.
Right.
And so you attach to my address book and register change notify with me, and if I move and I change my address there, you automatically get my new address. I don't have to fill out all those change address cards.
As long as you gave that entity access to do that. So it's important to note on each one of these primitives that the only way that someone could go and actively do one of these things is if you said they could. So in the company example you just talked about, they would have to you would have had to say yes.
So when I signed up for your service,
yeah,
I'd have a little thing I'd click on or something like that.
Yeah. So that your data stays safe. And it also kind of works out that with any of these models, not only did you had to allow me to have access to it at the beginning, but any subsequent time I have to still have access. It's not like once I have access, now I've got it forever. You could have given me access at some point and said, Shaun, I just don't want to deal with him anymore, and so I'm going to take access away, and now I can't ever see that again.
So then, so let's say, again, I sign up for a coffee service you're supplying, and I cancel the coffee service, but you still had a connection to me, and you kept on sending me junk mail, trying to get me to resubscribe again. I could take and then remove that, and when I moved, you couldn't then follow me through.
Right. So I thought I'd go through some of these operations. Maybe I think the first interesting one we should cover would be insert. So like what Mark was talking about, each one of these little operations or methods that you can count on at every HailStorm service starts with manipulating an XML document. So we've got an insert request here, and basically insert says, I want to point at a spot in the XML document, and I want to insert some data. So the best way to describe this is actually with an example. So we've got an insert request here, and what I want to do is, you get that? So what I want to do is say I want to insert a request. And I want to select. Of course, we're using in this particular examples nodes like A, B, and C just as an example. But we could pretend that we're working with the my address example. So in this particular case, we say I want to do an insert request, and I want to select C. And if I find C, the node C, then I want to insert data Z. So you see on the left-hand side, where there's several nodes actually. There's the B node that has an ID of 2. There's the C node that has the ID of 3.
Maybe highlight that with the mouse directly so that they can't see you pointing at the screen.
Yeah. So there's this node on the before, and then there's also this other C node before. And so we've said that we want to select any C node and insert the data Z. And so actually, because there are two nodes with this simple insert operation, we've said that we want to do a select. Z will get actually inserted in both places after the fact. It's over here.
So both in the C node with ID 3 and the C node with ID 4
Yeah.
are both going to receive a Z object.
Yeah, this is like if I wanted to insert a contact or something like that. In this particular example, in our insert request, we've been very nebulous as to which C we wanted to actually attack. So I just wanted to point out that that you can do inserts in multiple places, and it's up to the onus of the developer or whoever's doing these insert or update or replace operations that they need to be specific about what they're targeting. Or they can actually say, I think there could be two or more there, but I want to, if you get two matches, I want to get an error on that. And I was going to show you an example of that in here in a second. So,
But I suppose there might be cases where you would want to take and insert a particular item in every occurrence.
yeah,
of a particular
exactly. So with any insert or update or delete operation, we've got these two verbs that kind of flow with every request called min occurs, max occurs. And what min occurs says is the default value is 0, and min occurs says that, hey, if I don't really care if I selected something and you don't come up with a match, that's not really an error. But if I were to say min occurs equals 1, then when I do the selection on that node C that we were just talking about, there better be at least one thing that matches in that thing. And if there wasn't at least one or two or whatever we decided with min occurs, if there wasn't a match on that guy, then that's definitely an error, and you should return me an error. And max occurs works the same way, only at the opposite end of the spectrum, which is the default is unbounded. So I don't really, if there's 0 or if there's none, it doesn't really matter. I don't care how many of these things there are. But if I wanted to do an insert operation on 5 contacts and I set max occurs equal to 5, and I went to do a selection on that thing in 6, there was actually 6 contacts that matched this selection criteria, then that's an error because that's not something that I was counting on. Does that make sense?
Mm-hmm. Mm-hmm. And you do that maybe if you did a query to the table and a few days later you're using your previously cached query.
Exactly.
This okay, I had 5 there. I want to now update all 5 of those with something.
Exactly.
And I added one additional to it. You thought I need to go requery it again.
Exactly. So in this next example here, let me guess if I can get it up here. Here's another insert request. And this time we want to be a little bit more specific with which guys we're actually going to go tackle. Sorry. In this particular case, we say we only want to do this if max occurs equals 1. So that is to say that I'm going to select C, and there better only be one C here. And so I'm trying to insert Z in node C. And as you can see down here, here's the before. So I'm trying to insert this node Z. There we go. I'm trying to insert this node Z into somewhere in C, and you can see by the data over here that there's actually 2 C's. But we've said max occurs equals 1, so we're saying that by God there will only be one match there. So you see the before here, and then over on the other side of the thing, which I can't paint very well, we saw that no actual operation, no Z got inserted anywhere, and that's because there were 2 C's here, and so
instead an error would have gotten thrown back to my application,
exactly.
And I could have requeried the thing, say, okay, well, gee, it's got more than this. Let's go actually find out what we do have and see if there's another item we need to set up.
Right. This next example here I'm going to gloss over because that has to do with attributes. And we get, so here are the kinds of things that can come back from an insert operation just as a high level. You can get a status success. Let me come back up here. You can come back, the operation can come back and say status success, and it says that the operation succeeded. It can come back as a failure, and the operation can come back also as said not attempted, which happens when we boxcar or chain together a bunch of requests, and each one has to succeed only for the next one to go. So
operation. Boxcar, why don't you explain boxcar?
Yeah, so it's like when I do an operation on, I want to do an insert here, and I want to do a delete here, and I want to do another insert here. And all these things have to succeed in order for me to do this next operation here. And if any one of these fails, then that's a failure, and I want to roll back all of these changes, or I only want to roll back part of them. So it's important to note that on some messages you can get back and say, hey, this operation you wanted me to do, if you're trying to do this boxcar thing, it may not have even been attempted, and so that's all we're communicating.
Because something before it failed.
Yeah.
Now, boxcar, is that like creating an atomic operation, kind of?
They're not atomic in and of them. They're atomic in and of themselves, but they're not atomic. You could have an operation could have happened in between some of those sub-operations, but each operation in of itself is atomic. Does that make sense?
Right. So if you have a boxcar of 5 operations, each one of those 5 is atomic, but the 5 as a whole is not atomic.
Right. Something could have happened between 4 and 5.
And then what's the benefit of boxcaring then?
Mostly so we can reduce, when we ship one of these requests over the wire, we can do a whole bunch of operations all at the same time. And
Oh, I see. So rather than having to do a server translation.
yeah, every single round trips every single
Right.
time.
Right.
Yeah. So some of these next methods I thought I'd cover. We got a delete method, and delete basically, its operation is to point at a node or node set, because once we give a selection criteria, which is basically like XPath, once we give a selection criteria, multiple nodes can actually match. So this is the same kind of operations happen here. So we say, let's take this example. It's best. So we're going to do a delete request, and we're going to say, I want to do a delete request, and I want to select C. And as you notice down here, C, there's actually 2 C nodes with ID of 3 and ID of 4. And we never.
This is the same data structure being used all this time now.
Yeah,
with
yeah.
2 C nodes.
Yeah. So in this particular case, we said we want to select C, but we didn't give any more predicates or any kind of extra knowledge. So we're going to delete them both, because we matched both of those nodes, and you never told us to do anything different. So now we can do the same thing with this max occurs, like I was talking about before. We've said in this particular case, we say, okay, I want to do a delete request with max occurs equals 1, which means that there better only be one of those nodes there. And if there's more than one, then I don't want to do anything. So in this particular case, we got the same thing, C of ID of 3 and 4, and we wanted to delete node C. So in this particular case, nothing happened because there was a match of more than one.
So if I instead there said min occurs 1, it would have deleted both of them.
If you had said min occurs 1, that means that there must have been, you need to have at least matched with 1, right? And so it would have deleted both.
And if the data didn't have any C's in it at all, it wouldn't delete any because there's nothing there, but it also would give me an error back in response.
Yeah, it would have said nothing there. You would have got response that it wasn't an error, it was just nothing happened.
Right.
So, and the same thing here with delete. With all these operations, you're going to find a lot of commonality. Like we said, we're trying to build a platform asset along all these things. So all services look the same. So you're going to get the same kind of responses, and it's a success or failure or not even attempted. The next one I thought I'd talk about is replace. So replace is not exactly like an insert. It's like a delete and an insert that happen atomically. So it's like if I want to atomically replace your last name from Bob to Charles or something like that, or your first name from Bob to Charles, then I would use this to do that atomically. And it has exactly the same primitives that you saw with insert. You basically specify, let me get back up here, you basically specify where you're trying to point at, the selection criteria, and then once you've found the selection criteria, what exactly do you want to replace? So in this particular example, we say, hey, I want to replace the node C with, and anything that's inside C, I want that all replaced with this thing called D and foo. So, and we never specified any other criteria. So what's going to end up happening here is we say, oh, okay, so I got 2 nodes here that matched on C. We've got the first node and the second node, and over here on the other side we see that both nodes, the interior contents got splatted.
Now what if I wanted to take and replace what's in C with foo, but I wanted to retain some of the information that was already there, or somehow use that someplace? Is there a way to do that, or would that, could I not do that with
insert? You can use insert to do that. Is that what you're after?
Well, I'm just thinking that you're saying here you're actually replacing everything with foo.
Of what this matched with. So
yeah.
So if let's say you didn't want to replace everything inside of there, what you would end up having to do is this selection criteria. This is at a very high level right here. It's just the node C. You could have said C/D/E. I only want to replace this little node inside of here rather than the whole everything within it. You have to be a lot more picky as to your selection criteria. Does that make sense?
Okay. Yeah.
Same thing here occurs with, this is another max occurs example with replace. So I say I want to select C again with max occurs 1, which means there better only be one of these guys. And so what ends up happening is nothing ends up happening because we ended up having 2 C nodes, and you said there only better be 1, so nothing happened. We're going to return you back nothing. So those are the basic primitives. So there's the same thing with here with with replace, you get the same kind of error codes come back, success, failure, not attempted. And now this not attempted thing, here's where this thing comes into place. We have this method called update, which is basically a container for each of those other atoms that I just talked about, like insert, replace, and delete. So within update, you can have many insert, update, insert, replace, delete type primitives, and they can be chained together in an entire boxcar type of mechanism, like what we were talking about. So
update is a boxcar.
Yeah, yeah. Let me get this is a long one. Okay, so here we got an update request, and so in the first update request, we got this thing update block, which is the entire container for everything, and you see this. There's this very interesting thing here that says on error, roll back and fail, which means to say that for every one of these little sub operations within here, if any one of them fails, I don't want to do the whole thing. You should just roll back every single thing that we did. So we actually do that at the service. So so the first operation we wanted to do is we wanted to do a replace request like we talked about before, and we're saying the thing I'm actually looking for is something with an ID of 3. And the important plot point here is that this update block up at the top, he actually sets the tone for the entire operation. You'll notice that here he says, hey, I'm only going within everything you find within me, I only want to go after the node C. And so everything down here, every operation down here is actually relative to the update block that set the tone. Does that make sense?
Yeah, it's kind of like a with statement.
Yeah,
yeah,
exactly. So the first operation we want to do here is we want to do a replace request, and if you find something, we're actually looking for an ID of 3, and if you find an ID of 3 that matches to C, then I want to replace that with a little attribute. I want to add an attribute in there to change it to ID of 77 and put a foo in there. And this next operation is a replace request to say I'm looking for anything with an ID of 4, and if you find that, then I want to put an X in there and replace that. And so and down at the very end here we do a delete request, and we say, hey, if you find an ID of 5 in here, and there better only be 1, then I want to delete that. And so what ends up happening is right here. So in the first request we wanted to do an ID of 3 and replace it with this over here, this ID of 77, and put a foo in there. So that looks like that worked. The next thing we wanted to do, looking for C of ID of 4, and we wanted to put this new node over there. And for this last guy 5, we wanted to delete that whole thing, so that worked. And the important thing with update is you can actually specify the semantics of if the thing succeeds, I want to roll back the entire thing, or if it doesn't succeed, I don't really care, just keep on going, or that kind of stuff. And when you get a response back from an update, it's going to tell you every single thing that it did. It's going to say I succeeded. Let me find a response here for us to look at. It's actually pretty interesting. Oh, it's right here. So here's the whole update response. And so it's going to give us a summary of everything that actually happened. So it's going to say, hey, on this update operation of ID of 10, which you tagged up here, let me roll back up here, ID of 10. Where'd it go? Right here, ID 10. So we tagged that operation. This is to give us some context so we can correlate it after the fact.
So that'll be used in the response back.
Right, yeah. So we say ID of 10, yeah, that turned out to be a success. And then we did another update operation for ID 20 that we tagged up for that second replace. That was a success. And for this delete operation, which was ID 30, that was a success as well. And here's where you find out about individual failures. And this last part here, this change number summary, is actually this very interesting thing that for a client-side cache, for all the data we have inside of HailStorm, it's actually tagged with a change number to say that, so I can have a client-side cache to say, I know what version of the data is here inside me, and I think I know what's inside of you at the service, but by having that, we can kind of have these client-side caches, and what ends up coming back on some of these operations is, okay, the following changes actually happened, and here's the new change numbers that are actually occurred. So
I would then update my cache to reflect those new change numbers.
Or it actually teaches you so that you can go issue an intelligent query the next time around to get what the most recent changes are. So that's important if maybe you didn't see the request to begin with.
So I could then, if I had a cache on my side with a change number, I could then ask the service, here's my change number, is that the same change number you have? And if you do, I don't need to worry about pulling all that data down.
Right, exactly. Okay. We can get into more of these update requests, and they can get more and more complicated. I thought I'd glance over some of this and get into this final guy, which is change notify, which is what we kind of talked about. This is a long one. Oh, sorry, I almost missed this one. Query. We got to be able to query the data besides inserting, updating, replacing, that kind of stuff. So with query, you can actually, it's just like the select stuff that we did before. You actually point at a node set and you say, hey, this is what I want to look at inside the data, and it'll give you back it'll give you back whatever the contents of that XML document are. And we actually have a couple different ways to do that. One is with XPath, and you point at a node set that can return multiple things and say, I'm looking in my contacts for this kind of stuff, and just return that to me. And you can do predicates and all that kind of stuff. And another one is XML query, where you can say, I want to do a selection, basically almost like a select statement in SQL, to say I'm only interested in this kind of search criteria. So a little bit better with the select part of the equation. And so I don't even think we give an example here, but all select is in all those other places where we did insert, replace, or update, and we said select. That's what this query is. We just select a node set and get back an answer. There is this one very nifty kind of query request, which is what we say a change query, which is you say, this is the change number, just like what we talked about. This is the change number that I have here. What change number do you have there? And if they're not in sync, you need to tell me what are all the kinds of operations that I need to play back to you in order to get it in sync.
Mm-hmm.
You know what I mean? It's almost like a diff of the two. And so you say, I'm interested in, I have this version, you have that version. If they're not in sync, tell me everything that I need to do here internally to go do it.
So the notion there is to take and try to decrease traffic as much as possible, so I'm not constantly grabbing the data every single time just because it might be out of date.
Right.
I'm actually finding out if it's out of date, and if it is out of date, rather than pulling down all the data, I'm just finding out what do I need to change in my data to make it proper.
Exactly.
That must mean the servers are storing an awful lot of information then.
Right, yeah. For the sake of time, I thought I'd jump down to this last guy, change notify.
Yeah, that sounds like an interesting one.
And he's basically the same as query. Looks like we don't have it. He's basically change notify is like what we talked about before. It's the same as query, where you point to a node and you say, I want to be notified when anything changes here, and here's an address that I want you to tickle me at when something does change. And so that's basically the gist of it.
Mm-hmm. Now, I assume that an awful lot of work went into planning this whole model of the add, the update, the delete, the query, and the change notify and stuff like that. What was the process like in actually coming up with this whole concept of the XMI and the structures and the templates and
You mean what was the process like?
Yeah, I mean, what was like being part of the process of designing this stuff?
It was interesting. We came out with.
I'm sure you just didn't sit down in your kitchen one night and write all this stuff down.
No, certainly not. Most of the stuff was we came out with straw man of first we only had some operations like query, add, update, delete, and as it turns out that after we went out through this software design review to a lot of people, they said, well, this doesn't really work very good. You need to do it like this, you need to do it like this, or I need a client-side cache, and you need to tell me of these changes that happened instead of me having to sit there and poll you all the time. So almost all, a whole ton of this is actually feedback from, people from within the company as well as outside the company. So
you've been able to provide feedback with people
tons
outside of your group
yeah.
in focusing on this sort of stuff. So it's not just being built in a vacuum.
Right. Not being built in a vacuum, and for some of these schemas, be it either my inbox or my notifications or my address, we're not the experts in that. So we always in those cases had to go and get outside aid for maybe there's an internal group that can help us, or maybe there's external folks that can help us to understanding the schemas and how would this best be fit together. So a lot of this is still in its infancy, but we've gotten tons of feedback on how to make it better all the time.
Now, where are you at in the development cycle, and how soon we might actually be able to see something in code against, perhaps?
By the PDC, which is in October, we want to be able to give you something called HailStorm in a box, which is that on a local machine, without hitting passport or any internet type of things, I can sit there and do query requests and inserts and replaces and all this kind of stuff to some sample services, so you can kind of get the knack of here's how I shoot a SOAP message off, and here's the kind of answers I get back, and start getting you to have a tool set that you can you do transforms on the data that comes back, or do joins or whatever you want to do. But
it's kind of like a simulator.
Yeah, well, I mean, it's actually calling real HailStorm services. They just happen to live on your machine, but we think of that as kind of like a good training place to start your development there and kind of get accustomed to it, and then maybe graduate to like a passport test site or something like that, where now you're starting to hit real passport and get real authentication going, and then from there graduate again to to the real internet program of HailStorm.
Well, thanks. What do you personally think about HailStorm and how this is going to change the model for applications moving forward?
I think a big thing would be that it's, well, two things: cross-platform or open access, and that any platform can call us, and you don't have to have. I always get asked this by everybody of like, what version of MS-HTML.dll do I need in order to call HailStorm? It's like nothing, absolutely nothing. If you have access to a sockets library, you can call HailStorm. So that's one thing. And the other thing would be just make it easy to do some of these web services and tie it around a user's data and put them in control of their own data, so that so that they can add people to allow them to see their data and revoke it, and get to this world where I don't have my data sprinkled across everywhere in the known universe of, you know, Amazon's got my zip code and this person's got my zip code, and I moved recently, and so now I got to update all those sites, and I don't remember all the passwords that I was supposed to enter in everywhere, as well as the data that I might have given them or my old credit card. So we can start to get away from that world. I think that's the biggest thing as well.
I know I have trouble. You know, people change their email address for some reason or another, and I might change it in one address book, but I might forget the other address book, and it's
exactly
end up getting in a mess that way.
Yeah.
Well, thanks, Shaun. I appreciate the time you spent sharing this information with us. Now, since I saw various Microsoft confidential statements on this document, I'm assuming this is not a document I can send out to my viewership.
Not yet, but we want to have something midsummer to PDC to quite a few people to get more feedback on this. So we're kind of going through our first rev of feedback we got back in March, and we're looking to get more feedback here in a couple months.
And the place that they'd be going to find out more information about HailStorm and .NET services overall is
Calling you at home.
Calling me at home. Okay, I'll give you my home phone number. Or calling you at home. I'm giving you your cell number instead. msdn@microsoft.com/net, and we'll have links to HailStorm information there, so they can get these documents and they come out, as well as finding out the toolkits and the SDKs and so forth.
Right.
Thanks, Shaun.
No sweat.
Well, hopefully that gave you a nice little insight of what HailStorm has in preparing for you. Now, granted, we didn't show you how to actually write a HailStorm application. That'll come up in a later show once we actually have an SDK and toolkit available. So thanks for joining us, and stay tuned for the rest of the show.
Many of you are probably very familiar with the samples that MSDN produces, such as Duwamish. Well, with me today is Steve Kirk. He is an application architect with the MSDN Architectural Samples team. Steve, welcome.
Thanks, Erica.
So, Steve, tell me about how long you've been doing samples for MSDN.
I joined the team in July of '96, so almost 5 years now.
And what type of samples have you worked on?
Well, the first one, we've built several in the course of that time. The first one was something called the corporate benefits sample. It was part of Visual Studio 97, and it was an early component-based application. We compared use of VB's remote automation versus DCOM in that application, and did some work with VB interfaces as well as web interfaces.
Okay. And I imagine you were pretty heavily involved in writing a lot of articles and samples for Duwamish.
Yes, yeah. But actually, before Duwamish, we did another fairly good-sized sample called the help desk sample, which was the first application that we did that used Microsoft Transaction Server with our component-based application. And then back in '98, we started out with Duwamish books, and it's been kind of fun to work with that over the time, because since '98 we've gone basically from a desktop VB application through to an n-tier distributed web application. With Duwamish Online, we went to a full Windows 2000 server application with load balancing on the web tier and a failover cluster on the database, and we used Microsoft message queuing as well as a web interface. And then now the Duwamish sample is being used with Visual Studio.net. The Visual Studio.net team actually rewrote the application for .NET using the .NET framework. And so it's part of Visual Studio.net. So it's kind of interesting to go from a Visual Basic desktop application to a .NET
yeah, it's had a long life cycle.
Yeah.
I know that sample was very popular. The feedback was always so good. Can you tell us a little bit about what type of samples you're working on in addition to the Duwamish.net version?
Yes, right now we're working on a project called Building Distributed Applications with .NET. And what we're doing is, instead of working on a complete end-to-end application like Duwamish books, we're actually working with fragments of applications. We're calling them the piece's use case implementation. And by focusing on a smaller fragment of an application, on a feature or a use case, what we're able to do is to focus on the design issues rather than the end-to-end completeness of the code. And this really allows us to focus on the issues at hand.
So tell me a little bit about what things you did before Microsoft.
Well, I came to Microsoft in '96, and before that I was a partner in a small 2- and 3-person development firm. We wrote CAD and database applications primarily for architects. We basically drove CAD systems from data, from, say, a space program in a database, and then going the other way did space takeoffs and so on from actual drawings.
So did you study architecture as well?
I did. I studied architecture and fine arts. Before I became a partner in this development firm, I at one point moved to New York to be an artist, to be a painter.
Well, painter, that's great.
Yeah.
What type of paintings did you do?
Well, basically what I was most interested in was sort of a conceptual branch of painting where the script that motivates the creation of the painting is sort of separate from the actual artifact. For instance, the script might be something like draw a closed shape on a page and fill it in, and then of course the implementation of that being sort of a separate thing, generating this artifact. Which could be repeated with sort of the thing that generates a nice variation. The actual hand or the accidents in the implementation of that script basically create some interesting variation. And when several implementations are made and they're installed together, it creates kind of a nice variation.
That's really interesting. Wow. So what is the actual mechanism or the means that you would produce these paintings?
Well, I did a lot of different experiments with implementation. Very often paint on paper, and very often pieces of cardboard. But I also did a fair amount of, in fact, sort of one entree into software development was in actually building machines to actually implement some of these scripts as well. It's kind of interesting from a very experimental point of view.
Machines that would make these paintings.
Right. Yeah. Yeah, so that stays in a very experimental stage. But
so was that your migration from the art world to computer science?
I think that sort of got me going.
Yeah.
Yeah. But it's funny, some of these scripts are very much like software. Scripts to sets of rules to specify an action are really truly software programs, and so I sort of see a lot of similarities between those two endeavors.
Yeah, I'm not sure many people do see that. That's great that you do.
Yeah.
So do you still paint today?
Just a little bit. My day job takes a fair amount of time.
So who are some of your favorite painters or artists, past or present?
I think one person that works in a very similar way that comes up is Solo Witt, who actually develops these scripts, and then they're actually drawn. Series of drawings are actually drawn on a wall. Another artist that I like very much is his name is Trimpin. He's actually a composer and sculptor, but the scripts in his work are actually represented as MIDI instructions, and rather than having music be synthesized and come out of computer speakers, he actually drives real transducers moving actual musical instruments, pulling strings on guitars and blowing air through instruments and so on. And it's quite wonderful, the actual using the script to influence something in the real world.
Yeah, the machines are taking over the art world as well, somewhat. Well, you still need someone to program it. So.
That's right.
That's great. So what other type of things do you do outside of work?
I think gardening and a little bit of cooking are some of my favorite hobbies with my wife. But I also I'm on the board of a dance group, a modern dance group in Seattle, and that's kind of a nice way to support other artists in the community.
That's great. Do you dance yourself?
No, I don't.
You stay on the board.
Yeah.
That's great. So, as an architect developer at Microsoft, where do you see, or what are some of the things that you're excited to see technology move into?
Well, you know, with what I'm really enjoying is working with the .NET technology. I mean, it's basically so much easier to implement a distributed application. Going back and looking at what we had to do with DCOM and some of the very good things with DCOM, but web services are just a wonderful way to componentize code. Very nice way to organize code, and I think that has just an incredible amount of potential for making it easier not only to design but then to deploy applications, to actually manage them. I think will help quite a bit.
Yeah.
It's been kind of a nice experience working on these samples, because we do everything from design the architecture of the application to actually code it and then implement it and then test it and then write about it. So going through that whole range of work we've found out a lot about how hard, you know, what the other sides of these applications are, what it's like to deploy them, for instance.
Right.
And how well an application can stand modifications to the code, you know, once the thing is up and running. That's very interesting.
That's great. Well, Steve, it's been great talking to you. Thanks for joining me today.
Well, thank you. Thanks, Erica.
Thanks for joining us for another episode of the .NET Show. Hopefully this little sneak peek into HailStorm gave you some information that will be useful in your development efforts.
And stay tuned for the next episode, where we'll talk about programming tools for .NET.
And until then, we'll see you on the web.